Hi everyone, in this lecture we're going to be covering recursion, and before we delve into it, I just wanted to reference one more piece of notes for our GUI exercises with tkinter. If you could take a look at the OOP calculator, this is very useful because it shows how that calculator class in tkinter that was made earlier, the larger one, works inside of classes and OOP concepts. So make sure you take a look at that before looking at recursion. Excellent. So I went ahead and I made a recursive practice.py file. And before we actually look into how to code recursion, a general what it is a recursive method is one that is going to solve a certain problem that it is given by calling on itself. Now, these are very helpful, and in languages that don't use loops, such as Lisp and Scheme, recursion is used all the time. And it's very weird to wrap your head around coming from loops, but we'll look at some examples coming from loops and show how it works in general. As a note here, recursion is something that is not familiar to us, and it is actually kind of counterintuitive to what we've been learning in some areas. So make sure that you practice it a lot, or else you're going to be a bit lost sometimes. So make sure you take a look at all the examples provided and try to code them up on your own. Now, a recursive method is going to consist of two parts, and essentially it is going to consist of a base case. And again, these parts can have one or more base cases, of course, but each recursive method is either going to have a base case, which is something that is happening that ends a recursive program, or it has a recursive call, which is essentially a subproblem of a recursive call. So essentially, we're trying to go to a lower problem. So again, a way that we can look at recursion is to break things into steps and subproblems, smaller and smaller subproblems, until we eventually reach the solution and we can return that solution. Now, a general example that we can look at is counting down, which is a problem where we're going to count from a non-negative integer n, which is greater than or equal to 1, and we are going to continue to count down from n until we hit 1, and then we're going to print out blast off once we're at 1. So why don't we do this using loops? So I'm going to do a countdown loop, and I'm just going to call this countdown L, and then let's say, oops, let me make it a definition first. So def of countdown L, and it's going to take in a non-negative integer n, and I'm going to say while n, see here, while n is less than or equal to, or excuse me, greater than or equal to 1, what I'm going to do is print out n, and then I'm going to decrement n, right? Because I kind of want to reach that line at the bottom. So I'm going to print out n, and now as soon as this loop is done with, I can print out blast off. And now let's see if this kind of works here. And let me actually call the function after we define it. Cool, it looks like it's looking pretty good. We go from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then blast off. Now, why don't we try to abstract this a little bit more for our recursive practice? So again, a recursive call inside of your functions is going to call itself, and there's not going to be a loop. So we can't use a loop to solve this problem. So you might be wondering, well, how do I actually solve this problem without using a loop? So why don't we make a second function here? Let's just call this countdown R, and I'm going to give it the parameter of n. So this is going to be the recursive version of it. Now I'm going to call it CR for clarity's sake over here, and I'm going to give it an n. And now what we're supposed to do is we're supposed to count from n down to 1, including 1, and then print blast off. Now, how do we actually get this to work here without using a loop? Well, first of all, if I call it with CR of 10, let's try to do something here where I just call it with CR of 10 and then print out n. So I can print out n over here. So we're at a good start here, and let me go ahead and just try to call countdown of R pretty quickly as well with 10. Let's see what happens here. So it looks like we got 10. I'm going to comment this up for the time being just to show off what's happening. Okay, so we get 10, but that's not good. And now in our notes, it's saying that a recursive function calls itself. So what that means when we say it calls itself is that it's going to go ahead and call countdown R again within its own function. And now, what do I provide countdown of R? I need to provide it a parameter, right? Because n is created right here. So what do I need to do here? Well, what happens if I just provide it to be an n? Uh-oh, it looks like we're getting something that looks a bit like an infinite loop. And now let's let this keep running. you're eventually going to hit this error that says recursion error, and it says that the maximum recursion depth exceeded while picking an object, which is a fancy way of saying that we went past the recursion depth and we are out of bounds, essentially. Or sorry, it's a recursion error. You might get these quite a bit, and what's happening here, if we actually try to lay out this code, what's happening, we call countdown of R of 10 in this line of code over here. Let's just say it's right here. And what happens is CR of 10 jumps into this function of CR. N is going to be equal to 10. And what does it do? It prints out N. And then it calls CR, prints out 10, and then it prints out 10 again. And now we're supposed to get to a certain level though, right? We're supposed to go down. So how do we go down? Well, what we can do, instead of printing out CR of 10 like so, why don't we try printing out CR of 10 minus 1? And that will get us to the next level beneath 10. So the way that we can actually code this is over here, I'm going to recursively call countdown of R of n minus 1. So if I provided 10, this will be 10, and then it goes 10 minus 1, which is 9. So now 9 goes up here. I print out 9. 9 minus 1 is 8. Now 8 goes up here. I print out 8. 8 minus 1, and so forth. So let's go ahead and run this. And it looks like it's doing better, but now we're having this issue. We went way out of line, and now we are not hitting the end, and we get another recursion depth exceeded. And this is where we need that base case. So the base case is going to be the portion of the problem for which an immediate solution is known. So what will be our base case in this scenario? Well, if we look back at our notes, probably from n down to 1, printed 1 per line. So when we hit 1, that is going to be our base case. So what we need to check here before we do this recursive call is something where we print out n, and then we say if n is equal to 1, we want to essentially say, hey, we can't go beneath 1 anymore because 1 is the end. And so let's go ahead and just try to return from this function. Now, if we go ahead and run this guy, now we see that I go from 10, 9, 8, 7, 6, all the way down to 1. And essentially, this logic, what's happening right here is something like this within the stack. So you can see here, my writing's atrocious, sorry, but essentially what's happening is we keep going down until we hit this if statement, and once we hit the if statement, we return and break out of the statement. You could put an else here as well, but the return will break it out. And now we also need to put blast off, so blast off should only occur when we're at the very bottom. So now I could say blast off, and now we could see if we go ahead and try to recreate these two functions together, we can see that we have one that's a loop that's doing it and one that's recursively. And recursion is usually more effective in some regards when we're using loops or some certain algorithms that you'll see later. But in our scenario here, they're doing the same thing there. Now, one more thing that you might notice here is that we don't have any loops inside of it, and that's the entire point behind recursion again, is that if you don't have a loop inside of your language or anything, you won't be able, or excuse me, you will have to rely on recursion. So again, this is kind of our stepping place to get to this base case, and the base case will end our recursive calls. So please go ahead and take a look at the examples of recursion. This is a very bare bones example, so in the next lecture we'll look at more advanced ones. But please, the main thing that I want to reiterate with recursion is that you need to practice it a lot. So you're going to see lots of examples in lots of areas. Don't get overwhelmed with them. It's a bit confusing at the start, but please practice it, and eventually you'll kind of grasp onto it and see how it works in comparison to loops.